you will examine both types of channel selection devices. Changing channels may be accomplished in one of two ways. You can change the inductance of the tune circuit while leaving the capacitance fixed, or you can change the capacitance while leaving the inductance fixed. It used to be that the most common method was to vary the inductance of the tune circuit through a mechanical means. In today's modern television receivers, however, it has become preferable to vary the capacitance of the tune stage through the means of solid-state devices. We will first examine the older style mechanical tuners. Here you see a drum-style tuner device used for VHF channels. The drum tuner consisted of 13 individual sections which contained the tuned coils necessary to receive the 12 VHF channels, and one section was tuned for the UHF setting. These 13 strips were configured into a cylindrical shape, thus forming the appearance of a drum. Each individual section contained the coils necessary to select a particular channel frequency. As you noticed, there are typically 4 coils for each section. 2 of the coils were used in the RF section of the tuner, one for a tuned input and one for a tuned output of the RF stage. Another of the coils was used for the oscillator portion of the tuner, and the final coil was used for the mixer portion of the tuner. Basically, the drum switch was designed so that as the tuner shaft was rotated from one channel to the next, a group of tuned coils would be connected to the appropriate circuits within the VHF tuner. Each time the shaft was rotated, a new group of coils would be inserted or connected to the RF amplifier stage, mixer stage, and oscillator stage. Each group of tuned coils would be factory designed and preset to receive one television channel. As you can see, by rotating the tuner shaft, you would be changing the bandwidth operating frequency of the affected circuits, thereby allowing channel selection. Here you see another common mechanical tuning device. It is referred to as a wafer switch. Even though the wafer-style tuner performs the same function as the drum-style tuner, it is considerably different. Notice that each of the 4 wafers contain 13 tuned coils. Also notice that the last 3 coils are wired in series with one another. Each wafer contains the tuned coils necessary to receive and select one channel frequency at a time. The inductance is varied by adding the inductive value of the selected channel when going from TV channel 13 to TV channel 2, or it is subtracted from the value of the selected channel when going upscale from the TV channel 2 to TV channel 13. When the channel selector is positioned on channel 13, the other channel coils are removed from the circuit. And when the channel selector is positioned on channel 2, the total reactance of the circuit will be at maximum, since all the coils which are mounted on the wafer are now in series. The first wafer in the wafer-style tuner is used to control the local oscillator section of the VHF tuner. This wafer section generally contains individually tuned coils for the oscillator section instead of the series-connected coils used in the other 3 wafer sections. The mechanical UHF tuners generally used air variable capacitors to perform the task of tuning. The air variable capacitors would have one or more rotating plates for each tuned section of the tuner, and one or more fixed plates for each one of the rotating plates. As the shaft was rotated, the plate area of the capacitors would change in value, thereby changing the operating frequency of the stage the capacitor was connected to. As you can see, the UHF tuner would vary the capacitance of the tune stages instead of the inductance as was used in the VHF tuning devices. Also notice that the UHF tuner only controls 3 stages instead of the 4 stages controlled in the VHF device. The UHF tuner will